As David mentioned, my name is Ben Bangert. I'm a senior software engineer at O'Reilly Media. I work in the online publishing group there. And today's talk is mainly going to be around WSGI and developing reusable web components with Python and future Python web development as a result of using WSGI. So to get started here. Web applications with Python. I've been a fan of this for a while. There's a lot of really powerful frameworks available. A lot of large companies, like Google, for example, deploying Python web applications, and there's a huge library of Python modules to use. It's a mature language with an emphasis on backwards compatibility, except for Python 3000, which will have a few things, of course. And this all looks really good, of course, when we're talking about Python and web development. So what's the problem? This is twofold depending on who you ask and who you talk to. Some people say, oh, well, there's too much. But I'm going to break it down slightly differently. First off, our sessions, our request shortcuts, our response paradigms, they're all unique for every framework pretty much. You use Zope, you have one way of doing it. You use Pylons, you have a different way of getting the response back. Django, another way. All of these frameworks have a different way of doing these kind of very basic, simple things. There's not really any uniform way to deploy them. So everyone wrote their own server hooks. Some people say use mod Python. Some people say, no, we have our own application server. Just go ahead and run it as it is and proxy to it. There's not really any uniform way to get all of these things across. And of course, every time you change your framework means that everything you knew was sort of lost as well. Maybe you've learned how to use sessions with one framework. You change frameworks. They want to do it a different way. They want to save it a different way. And maybe it doesn't make you as happy as it did in the previous framework you used. And of course, reuse of the individual web components is very difficult, if not impossible. You just can't use these things between two frameworks. Sometimes you're even lucky to use two different web components within the same framework on two different applications, which of course doesn't make anybody very happy. So what's the solution? Well, the solution specifies a standard interface between web servers and Python web applications or frameworks. It was drawn up over 2 years ago, last modified April this year, and it goes by the initials PEP 333. It's the WSGI specification. And it was submitted by Philip Ebby, who's done a lot of great work in the Python community. So a quick peek at what one of these little tiny WSGI applications looks like before we go into the details and guts. Here's a hello world application. It's very basic, very simple. Just a few lines and you have a function, your web application that's called, it puts out some headers, and it returns the content of the response. We'll get into that a little bit more shortly. So first let's go over the basics of a WSGI specified web application. It's a callable function, an object that responds to call, any of those little things that you can just call right away, that's all it takes. It's given start response, which is called with a status code and a list of tuple pairs for headers before it returns a value, and it should be called only once. We have environ, which is passed in. That's a dictionary of CGI style variables. And the response is an iterable, a list, a tuple, an iterator, or generator. So let's take a deeper look inside of the environment. That's really where a lot of the power in WSGI comes from, doing stuff with the environment that's going between all of these little applications that all speak WSGI. We have a dictionary of strings. They're really basic CGI strings. You have your HTTP host, server name, request method, path info, query string. If you remember developing Perl applications way back in the day that were CGIs and you had to go and deal with all of these headers directly, this should look really familiar. You have a few WSGI strings that are put into this environment dictionary as well. You have WSGI.version, a URL scheme, WSGI input, which maps to the body of the request that's coming in. And you have server and middleware extension strings that are stored inside of environment. So of course that's great and everything, and you have a way to call your application, but what do we do with it? So let's look at a few basic examples. Let's say we want to get some cookies. here you have all you need, a little function, which takes the environment which we already looked at, which is being passed around. And it goes ahead and uses the cookie module, which comes with Python, and gets you back a dictionary-like object, which is your cookies. So you can start building these little functions now that you know about WSGI when you have an environment, and you can just pass in environment to a lot of them, and you can get back very useful sections of the request. They can work with any request that's coming in that speaks WSGI because all of them work with the same specification. Let's say we want to parse our query arguments. We have a little function here that, again, uses a Python standard module CGI. Parse the query string, and it's going to go ahead and return it. And of course, since that's all so easy and we want to do something a little bit more interesting, let's do a little something like intercepting requests and displaying interactive tracebacks. And there you go. Don't worry, I'll get into that later. So, interesting side effects of the specification. It only sets a base of required environment keys. WSGI compatible callables are free to improvise on this. They can add additional values and keys to the dictionary that's being passed around. They can put object references in there. They can expand a bit and do what they want to do, assuming that they're not stomping on somebody else's stuff, and we'll get to that as well. So you have middleware. This is interesting. If you have a simple specification that just says, okay, I have an application, it's going to be called like this, it needs to return like this, what can I do with it? So you have a very simple specification here. You're just being passed 2 arguments, you're returning content, you're calling start response. Now, this allows you to get a little creative. You can do stuff that doesn't necessarily involve returning a response right away. This is what middleware is. It's an application that doesn't necessarily do anything all by itself, but it works between the request and your application that's actually going to do something. Now, the most interesting thing of all that I really get keen about, as far as I'm concerned, this is a new layer entirely. The standard specification, and it makes reuse possible and easy at a different layer than it was before. Framework competition is great. We all see all of the different frameworks competing. But what are they reusing from each other? Not a lot. WSGI sets a very low barrier and a very easy to use interface that allows a new layer of reuse possible in your web applications. So to expand more on WSGI middleware, it acts just like a WSGI application. It follows the WSGI specification. And as far as anything is concerned, it looks just like another WSGI application. It's going to be called, it's going to return, all very basic. So it could decide to give its own response, or it could call your application. So let's take a look at a very small piece of WSGI middleware that's going to do something inside of the environment here. Here you can take a look. We have a basic object. We're going to pretend that you have a really cool WSGI application inside of your library, and it's called cool app. So you import it, and you have your randomware, which is just going to give you a random number. So we have right here environment. We're going to add something to it when we're called. So this looks just like a WSGI application once it's initialized here. So we go ahead and initialize it, and we give it the cool application. Randomware is going to go ahead and hold on to a reference to our application. And then when we call it, of course, we add an environment dictionary, and then we call it with the environment. And so far, does anybody have any questions? Is this all pretty basic? Yes? No? Okay. Here's a little bit larger middleware. It's going to hide an exception from a user. What if our little function throws an exception? We probably don't want to show that to a user or let it just explode. Maybe we want to give them a nice error screen. So here, again, it holds onto a reference of our application, and we have to get a little bit more clever. As we mentioned earlier, that start response is a function. The function should only be called once. So if we have something that's going to be calling our WSGI application we don't know if our application is going to throw an exception after or before it's called start response. So in our case, we're going to give it a fake start response. And all it's going to do is it's going to record whatever that function call would have sent out into an array there. Then it's going to attempt to call our application, and it's going to call the response on it if it went OK, and then it's going to return it. If it didn't go OK, it's going to go ahead and throw out an internal server error. It's going to set it, and it's going to go, sorry, our server had a really bad day today. So because we can start reusing things at this level, do you really want to write this every time you write a web application? Probably not. Maybe you're looking at a framework to provide this for you. You don't necessarily need to look at frameworks anymore. You can look at small WSGI middlewares and little components, and you can plug them in as you want. Do you want to capture your exceptions? Sure, go ahead and do it. And hopefully from this example, you can see, well, what if at my company, I need to email all of them, and then I need to do several other things as soon as an exception pops up? It's pretty easy. You just add it into your accept clause, send off an email, and you're good to go. Then you could just slot that in anytime you want to get out another WSGI application, and you have a reusable chunk of code there for you. We have what I call WSGI components. These aren't really WSGI applications that we looked at so far, and they aren't really middleware like the last we looked at. This is more similar to those little tiny functions. You want to parse a query string. You want to parse your form arguments. You want to get in there and do these pretty basic things that most people might rely on a framework for. Well, why rely on the framework? If you only need a few basic things, you can do them yourself pretty much. So WSGI components, they work within the WSGI specification. They avoid binding to a framework. There's not really any reason to bind to a framework. You're working with a specification. You know how it operates, and it'll always operate that way unless they change it someday. But you can always say, I want 1.0 of the WSGI specification. They're typically rather small. We already saw several of them. The parse query string, not very large. There are a few lines, maybe 100 or 2 lines for the big ones. Like that earlier one we looked at briefly, that was an interactive exception catcher. It can get pretty big, and maybe it's not very pleasant to look at, but they're not packaged. I mean, these are not really, really big pieces of code. Most of them fit in a single module. They handle small, typical web activities that you might find in larger monolithic frameworks. So you might be thinking, well, that's great, but I'm going to have this huge bundle of all of these little functions, these little middleware. Why have dozens of packages for all of these little bits and pieces? It can be a bit of a pain, and you're going to have a bunch of them to an extent. But one person out there decided, well, I'm going to put a whole bunch of them into one package, and he called it paste. If anybody's seen paste or any of the variants of it, a lot of people have always asked, well, what the heck is paste? What does it really do? So hopefully after this, everybody here and watching this will know for sure exactly what it is. First off, it's a package of common WSGI components and middleware. It includes little bits of middleware that handle a whole bunch of different things that you're probably going to want to do. These parts by themselves are really too small to merit an entire distribution. Plus, you'd have so many packages. I mean, who wants 300 packages for all of these little tiny bits? Many of them have dependencies on each other. Maybe your request object that deals with environment might want to parse the query strings. Maybe it wants to parse the form variables, wants to have something to handle headers. These are very common little bits, so it's very useful to have them all in one package. So you could sort of think of it as a tool set for your WSGI development needs. There's a whole bunch of stuff in there that makes it really easy to develop WSGI applications. You get reusable requests and response objects. For example, here's a little WSGI application that uses a WSGI request and a WSGI response object. And it goes ahead and loads up the request, loads up the response. And now all of a sudden we have an easy way, if rec.params has key method, then it could write out a response. You have a much easier way to get into your response here. You don't have to be dealing quite so much with all those raw CGI headers and all that kind of stuff. You have little wrappers that make it a lot easier to deal with this kind of stuff. For those that have used Django, the WSGI response might look familiar. It's 99% the same code with a few things added on to make it easier to get WSGI valid response kicked out of it. But really all it's handling for you in that response is it's making it pretty easy for you to set an encoding for your output. It makes it easy to set cookies, makes it pretty easy to set your headers. So it's a little easier than putting that all into a big headers tuple and passing it back out, and it gives you some nice ways to refine the control on it. What else do you get in paste? Well, we take the pain out of errors in paste. That is all it takes to get an interactive exception traceback for your WSGI application when you're using all WSGI. All you have to do is import eval exception and wrap your application inside of eval exception. Eval exception will now capture all of your tracebacks. It'll hold onto a reference of them, and it'll give you a very nice interactive debugger in the browser for going through the traceback. Maybe you want to email errors back. Could be a bit of code and other things. Here again, 2 lines. We wrap our application, we pass it an error config. This is just some keyword arguments. You want an SMTP server to be so-and-so, you want it to be a from address, a to address, a few basic things like that in error config, and you have email errors coming back to you. So paste contains a WSGI request and WSGI response object. It has exception handling middleware. It has various WSGI environment handling functions like query string parsing and multi-part form parsing. I should also mention that most of the things that it does, because it's pretty basic and because it's being used by multiple frameworks and a lot of different people, these little functions are very optimized. And it's very easy to do that because everybody's using the same base set of functions to work with here. We have included sessions, transaction logging, proxying, a mod Python script, static file serving middleware, and much more. So this is a whole bunch of common stuff that you might want if you wanted to make very basic, very bare applications for the web in Python. And you don't necessarily need a full framework anymore. You can just take the parts that you want, put them in a single area, and you're ready to go. But what else? Well, just because it doesn't seem like any framework is really complete these days without one of them, we even have pony middleware in paste, which of course makes a nice little pony. That's totally irrelevant, of course. So what other aspects of web application development drive people to frameworks? Because this is an interesting question that the creator of Paste, Ian Bicking, was trying to address. Mainly the thought was, all of these people making frameworks are repeating a lot of the same steps. They're doing a lot of the same things over and over again. It could be a real pain to do all of these, and wouldn't it be great if they were all unified into a set of tools that took a lot of these common parts that were underneath frameworks and did them for you? Paste does a lot of that already. You have a request object, you have a response object, you can have sessions, a whole bunch of advanced stuff that normally a large framework might handle for you, emailing your errors back. It takes them all out into one set of reusable parts. And of course, there's a few other things that aren't in Paste that frameworks do as well. Paste script handles project templates. When you make a new project in Django or in Pylons or in TurboGears, you don't want to make everything from scratch yourself. You want a starting point. You want something easy to make it, fast to get going. You want a project. So you have command line tools that go ahead and they set you up with a directory, they set you up with your basic structure. It seems like a pain to go and keep recreating these common parts. So this is in Paste script. You can make a project template, and it'll go ahead and kick out a customized project, a new one for you. And Paste script handles this part so that web frameworks don't need to re-implement it. So this increases reuse in the core tools that frameworks rely on. What's another section that frameworks rely on? Paste deploy handles. It gives us a configuration file for middleware and WSGI applications. It eases the loading of WSGI applications as well. So between Paste deploy, Paste script, and Paste, we got a whole bunch of reusable tools for making, frameworks, or for not using frameworks at all. You could go ahead and put together the parts you need, and you're essentially, in a way, making your own little framework. You have the parts that you need, and they do just what you need, and you're not burdened with a whole bunch of stuff that isn't going to affect you and is only going to complicate your life if you have a bug somewhere down the chain and you're going, where the heck did it come from? Oh, this module, I don't use this module. Why is it even here? Well, it's there because somebody else wanted it, and you can't get rid of it. So here's a quick look at Paste script at work. we create a little application. It goes ahead, and this uses a paste script project template. And it goes ahead and copies all the stuff out, and it makes several different directories, and it copies the files into them. Any questions so far? WSGI, middleware?
If you have one component, so if you have one component which catches exceptions and emails them, and another one with which wants to, give you an interactive debugger after catching exceptions, how would you? Is it possible to combine them?
Okay, so the question was, if you have two different WSGI components, one that emails errors back to you, and one that captures tracebacks and gives you an interactive debugger, can you combine them? You could, depending on how they worked. Obviously, if one of them has already caught the error and generated a 404 or 500 page, the other one probably won't catch it because it's no longer being passed an exception up the chain. Typically, in the web applications that I develop and the framework that I'm going to go over in a second here, Pylons, depending on the mode you're in, it toggles them back and forth. So if you're in production mode, it's going to email them to you, and if you're in development mode, it's going to give you an interactive debugger form.
That the composability of the components is limited by how nicely they interact with the Whiskey Stack protocol thing.
Their interaction is pretty much always by the WSGI specification when it goes up and down the chain. In this case, the thing that makes that particular condition a little different is that you no longer have an exception going up the stack after one of them has already been called. So you're looking at all of this and you're going, great. That's wonderful. If only there was a framework that used all of this stuff that we just went over. Well, there is. Pylons. I made this along with another developer, James Gardner, and we've had a few more developers come in and help us since then. First, appearances. I apologize if this offends some people, but it does look a lot like Rails at an initial glance. This is partly because it uses a re-implementation of Rails-style routing. And I say re-implementation at this point. I tried to port it, but I just couldn't read the Ruby code. It was code generation of code generation, and besides for being incredibly horrible to debug, it was pretty much unreadable to everybody outside of the Ruby core team, or the Rails core team, sorry. So we also ported the Rails helpers because a lot of them are really useful. They did some basic stuff, and just because it was done in Rails first, I have no problem copying a good idea. In Pylons, we have a very small core. There's not a lot in Pylons itself. We don't need to. All of the stuff is handled outside. It's handled by paste, which does a whole bunch of the common stuff. We have WSGI components. We have middleware. We don't need to do a lot inside of Pylons because it's already been done, and why would we want to reproduce other people's work? They've been doing it longer. They've got it down really well. And in pretty much every application I've seen where you have something that's hobbled together from scratch versus something that's been out in the wild being put through the test by a large community for a very long time, it's just not going to be done as well typically as a version that's already mature. Pylons is opinionated. Feel free to disagree with it though. It's not going to lock you into anything. It provides an incredible amount of flexibility inside your application. You can even do crazy things like not even use the Pylons application inside your application. You can make a totally different WSGI application out of the template that it gives you. So what do you get? You get an automatic installer, easy install and setup tools, handle the details, and for anybody that's used this before, you probably realize that, well, it mostly works. These tools are still getting more exposure. TurboGears uses setup tools, and a bunch of other Python packages are using setup tools. There's some bugs here and there, but overall, we found it to be working generally very well. TurboGears was kind enough to come along before Pylons and hammer out a whole bunch of the initial problems that cropped up with setup tools, so it's pretty nice nowadays. You have automatic generation of a project provided by PasteScript. You get a standalone server. It comes in paste. It's based on simple HTTP server. It's very fast and it works very nicely. You have multiple deployment options. WSGI is very nice in this regard. Because we have a single specification for how WSGI works, when people write server hooks for WSGI applications, they work with everything that speaks WSGI. So Django has a WSGI interface, so you can go ahead and put it behind there. TurboGears talks WSGI because the core of it, CherryPy, especially CherryPy 3.0, has a WSGI handler at the top of it. Pylons speaks WSGI, and a whole bunch of the other little frameworks that are coming out now also speak WSGI, like web.py, if anybody's used that before. So you have a very common deployment scenario that if you can deploy a WSGI application, you can almost always deploy any WSGI application. This is one of the initial things that WSGI was created actually to get around. You have a clean URL mapping, that's with routes. We could have gone the route that other frameworks have and trying to bring more stuff inside the framework. We've tried to push everything outside the framework into other packages that could increase reuse. Routes, I created mainly because I wanted to use it with Pylons, but I made it as a totally separate package. It has nothing bound into Pylons itself, so it can be used with other applications. People are using routes with CherryPy. They've used it with TurboGears, and I've seen a few people talk about using routes with Django as well. We have powerful templating options with Mighty, or you can use your choice of TurboGears plugin compatible templating languages. Rather than trying to go around and make it so that people can use any template engine they wanted to, we saw that TurboGears had already put out a nice plugin thing that allowed people to develop plugins for their templating language of choice. So you have a whole bunch of the common ones covered here. Do you want to use Django templates? There's now they call it Turbo Django, which allows you to use Django templates. If you want to use Cheetah, you can use Cheetah. You can swap out the default and use whatever templating choice you want. So you get traceback emails in production. You get an interactive debugger during development. We have a fairly solid MVC architecture. We have sessions and caching. We have the helper functions, which were ported from Rails. Again, these are in a separate package as well called web helpers. People are using these functions inside of Django, and I believe they're also using them inside of TurboGears. So there's, with all of these components, they're getting a lot of use outside of Pylons as well. We're getting bug reports back from people using them in other projects entirely, which is exactly what I wanted, because I wanted to increase reuse and I wanted to get a larger community regardless if they necessarily agreed with all the choices that went into Pylons. We have database integration with, it's not tied to any particular database. I'll show in a few minutes here how it works. It basically just uses some very plain Python import statements to pull in the stuff that you'd want inside of your controllers. You could use any database you want to. You just need to load it up inside of a normal Python module, and it's there for you. We also provide unit testing. This comes with Pace as well. Because the WSGI specification is pretty basic, it's fairly easy if you wanted to simulate a full request coming down the pipe. So you can get really powerful unit testing capabilities here because you know exactly what you're simulating to it. And as far as the WSGI applications are aware, it looks no different than anything else down the chain. So you can do some really good unit testing here of your applications by simulating requests to them. It comes with documentation tools, internationalization, error documents for custom error handling, and a whole bunch of other stuff. But really what's actually in Pylons, not a lot. Only 3,000 lines of code. This is a very small amount of code for a web framework, especially one that's doing all of this. This is mainly because most of the code is not inside of Pylons. It's inside of these other reusable sections that are being used by other people as well. PaceScript provides a project template. There's a small fork of the Buffet project, which is also the one that's used in CherryPy to get multiple templating engines working, so you can use whichever template engine you like best. It's a little bit of WSGI middleware and mainly a lot of configuration glue. We have to load up our WSGI application. We have to get all the middleware stack put together. You might not want to do that yourself, especially the first time you're using all of this. Pylons does it for you. So where's the rest of it stored? Beaker is a little package, WSGI middleware that gives you session and caching. Paste gives us a request object, error catching, and a whole bunch of other little bits like parsing our requests and that kind of stuff. PaceScript creates project templates, controllers, runs the application, and paste deploy helps with the configuration, and we have routes for our URL parsing. We get paste and nose, which is a small little testing harness and runner. It goes ahead and unit tests our application. You have your database of choice. You have the plugin API. You have web helpers. So what does the entire thing look like when you put it all together? Here's the stack that you get with Pylons. At the top, you have a request come in. It hits the pay server. You could go ahead and swap this out if you wanted mod Python, fascigi, SCGI, etc. Whatever speaks to WSGI, you can go ahead and use it at the top there. The entire application doesn't need a care. You have a WSGI stack. This is just a set of those little function calls as we saw wrapping up the WSGI application. Pylons provides you with a default one. It's inside of your project template, so if you don't like it, you could change it. You could put in whatever you want. If you have a special authentication system that has a middleware component, you can go ahead and slot that in. There's the actual Pylons WSGI application. This is what handles making sure that the request gets to the controller that it's supposed to. So it's going to go ahead and be the one that actually looks at the URL. It's going to parse out what controller does it go to. It's going to find the controller, call the controller. And then your controller is going to go ahead and talk to the model and view as it decides and return a response back up. Any questions on this? No? So the routing, it looks very familiar. It should look very familiar to anybody who's used Rails before. Just out of curiosity, could I get everybody who's used Rails to raise their hand? One person? That's it? Wow. One of the nice things that I like is that I don't have to write regular expressions too much. As you can see, I have 1 or 2 in here, making sure that my version is 3 digits back to back with an optional 3rd digit. But I don't want to write a lot of regular expressions just to get basic URL parsing to work. It should be easier, and I think the route system does a fairly good job of making it not only fairly easy to parse URLs, but generate them as well. So here what we have is the first argument is a name. If we want to name the route, we can, and it makes it easier to generate URLs later. It also provides a central part where URLs come out of. So if you move your application around and you need to change something that maybe 500 pages end up linking to, you have a central thing you can go back here and change how it links, and it's set everywhere. This is, at the bottom here, the default one. It just essentially says the first part of my URL is going to be the controller. There's going to be a slash. The second part's going to be an action. There's going to be a slash. The last part's going to be an ID. And that's how it decides what controller essentially to map it to by default. So here's all that routes does. Routes is going to look at the URL, and it's going to give back a dictionary with the keys set to whatever it came out to. And that's really all that routes does. It also generates URLs based on this, but it has no bindings at all to any particular framework. So if you like routes and you want to go ahead and make it work with whatever you're using, you can pretty easily. It also gives you URL generation. Let's take this route, for example. Here we have a pretty basic one. The route is named wiki, and inside there's a URL, and at the end we have page. Because it starts with the colons, it's a special variable that's going to be replaced. And that's what it looks like using it. This is inside the templating language Mighty, which again, if anybody's used Rails, it looks fairly familiar to Rails-style ERB templates. We'll call in the link to function there, and we're going to name what the link is, and then we're going to call URL for, and we're going to say, well, I want a wiki URL, and I want the tutorial page. And it goes ahead and generates that based off the information up there. The use in this was, at the time, even though we'd all like to have our URLs never ever change, which is what you definitely should do, sometimes URLs do change, and in this case, they changed a little too frequently, and I wanted to make sure that that always went to the right spot. So I had only one place that I needed to change to the URL that was going to be generated. Pylons gives you a few basic objects to make it easier to work with your application. Unfortunately, 2 or 3 of them have 1-letter initials, which I know is against the PEP 8. but they're used so frequently, it just seemed like you're going to get a, continuous stress on your fingers there if you have to keep typing them all the time. So you have H, which is your helper object. It's populated through a normal Python import. You have the request, which comes from the base WSGI request. You have a session. You have a render command and a render response. These should look fairly familiar to Django users as well as Rails users. Django has render to response. We have render response. They both do the same thing. They render a template and return it inside of a response object. So let's look at how a controller inside Pylons would get its form variables. That's all it is. You have the request.params, and we saw that also in the earlier example where we're using a WSGI request object. It's the same thing right there. So all we do is return the response, and there we go. Here we'll pass some variables to templates. If you've used Rails, you know that everything that you want to pass to a template, you assign to an instance variable. We didn't really want to do that. That's where C comes in. C is available inside of your template. So if you assign things to the C object, you can use them inside of the template. So there's what our template would look like. Again, this is Mighty, and one of the nice things that I'll go over later is that for the most part, Mighty doesn't impose another learning curve on you. You don't need to learn a very unique way of doing most kind of things. You got to use Python. You do have to make some adaptations because Python likes white space and HTML templates don't really care about it for the most part. In this case, the way to deal with that was this little bit. You have to comment and you have to indicate when that line of indentation is going to end because, of course, HTML doesn't really care. But otherwise, we get to use completely normal Python syntax. So we get for item and a c.fact items, and we go ahead and iterate through it, and they're inside of our variables then. So the big objective inside of Pylons was I wanted to increase reuse. I didn't want to just reuse all of this code. I wanted to reuse existing knowledge. If you already know Python, then what can I bring to the table on top of that? What other things could you learn faster because you already know Python? So let's go ahead and apply Python principles whenever we can. So the default templating provided uses normal Python syntax. You have to indent them, of course, and you have to do the extra little end if statement. It looks like it swallowed my white space there. That should be indented as well. Obviously, this can get really messy if you have a lot of nested if statements, which is why I generally would assume that you wouldn't want to have a lot of nested if statements inside of a template. That means that you're doing too much in one spot, and it should really be split up. So the goal here, why learn a new syntax for your templates? Why shouldn't you be able to use the Python that you already know? Variable substitution. Inside here, we have our variable. And anything in here is just evaluated as a normal expression. So you can go ahead and use Python syntax in there. If you wanted to call a function and have its output there, no problem. Go ahead and call it. This is all that you need for a controller. Not a lot. So where did all of these things come from? We have a render response, we have a base controller. We're getting all of this stuff in there, and we don't have to keep on importing a huge laundry list of stuff all over the place. So the idea here is, well, if you're going to keep on importing all of this stuff, odds are, well, maybe you come up with some new thing and you want it available in all of your controllers. What a pain it is to go through all of those controllers and add that new import statement. So let's use a normal Python import and go ahead and import a base set of names that we want available in our controllers. Here is the base one that you get in a new Pylons project. It has all of the basic stuff that you're probably going to want. A response, CG, a cache object, a request, a session, has a WSGI controller, and pretty much everything that you can want there. These last two are kind of important. We don't provide object relational mapper integration. We could tie ourselves to one, but then it just becomes its own little mess all by itself, typically. So what we do here is we go ahead and set up a models package inside of your directory. And you have a _ init file inside of there, and you can go ahead and define whatever mapper you want to use. It's imported as model, and because it's in here, and this module is imported everywhere else, you now have model available. So you get really easy, almost magic-like appearance of model everywhere, even though you didn't really have to do anything magical all by itself, just normal Python imports. Again, with pylonshq.lib.helpers, we're going to import that as H. Now we have H everywhere we need it for our helpers. You can go ahead and define whatever names you want in there. Again, a totally normal, basic Python import. So the advantage, of course, well, you always know where everything comes from. You could just follow it back. There isn't things being inserted in here magically behind your back. You're just importing them yourself. It's also pretty easy to see where you can extend your project with your own functions. Do you have some module that you use in all of your controllers? Go ahead and stick it in the base module, and there it is. Now it's going to be available in all of your controllers because it's imported everywhere. So there's a wee bit of magic needed to make them available globally and in your templates. This is taken care of by paste registry. Anybody can go ahead and use this. All it does is it makes it easy to get to specific objects that are created for the duration of a request anywhere else in the request. Because sometimes you're not going to want to pass something everywhere. For example, the C object. You might have several different places where you want to set up variables that are going to be used inside of your template. Passing these all over the place quickly becomes a very big pain in the neck. So we have a few objects that are a little bit magic to make it easier to deal with this. So keep your friends close. Most of Pylons is done through WSGI components, middleware, or separate packages. If you like something inside of it, you can go ahead and use it regardless of if you're using Pylons. Other frameworks also use parts of these. We have Rhubarb Tart, we have Clever Herald, some creative names here, and we'll probably have a lot more. Rhubarb Tart, if nobody is familiar with that, is sort of like a WSGI-based version of Cherry Pie. They like the object dispatch scheme of it, so they said, well, that's great. I want object dispatch based off of the URL, but I don't want all of Cherry Pie. I want very WSGI. So they made Rhubarb Tart, and it's very small. I think it's less than 1,000 lines of code to do it. So it's a very small little piece that does that for you. So of course the goal, stop relearning the basics. Take them with you. You already know how to use these parts, or maybe there's another part that you'd like to use. Why should you keep on learning it every time you move to a new framework? If the framework's WSGI based, you get to bring it with you if you want to, if they're not already using it. Make your new friends portable. If you have complex bits or even not complex bits, maybe they're just tedious. If you can write them as WSGI middleware, you can use them and keep on using them regardless of what framework you choose in the future. Assuming that it, of course, speaks WSGI, which a lot of them are nowadays. So WSGI middleware keeps web code reusable despite later frameworks. There's a few unanticipated bonuses in a WSGI framework. These parts make backwards compatibility very easy. I don't know how many people here have been using some of these new frameworks, Rails, Django, Pylons, any of these pretty much, and they've gone through a major revision already that's broken a good section of your code. And you're sitting there going, well, of course they didn't claim it was a 1.0, so I guess I should expect all my stuff to break every few versions, but that isn't very fun, especially when people are, of course, writing real applications with these frameworks now. WSGI makes it very easy to provide backwards compatibility. If the parts speak WSGI, you can go ahead and let people that are using an old version of it continue using those and just slot in new ones that also follow the specification. And that way, you get to keep backwards compatibility. The components follow a single specification, so if you want to swap them in or out, you can. And here's where it gets a little interesting. The PayScript project templates create some new possibilities that allow us to push the envelope. We can do something that maybe we haven't thought about doing before, we wouldn't want to do before, like subclassing an entire framework. Previously it wasn't possible or very easy. Definitely was a bit of a chore. PayScript allows project templates to inherit from other project templates. So let's say you liked everything about Pylons or one of these other ones, but you didn't want to use the session layer, you didn't want to use that request object. You can go ahead and make your own little project template, and you say, okay, I want to start with the Pylons project template, but then I want to change this file, and put in a new file here. And now you can go ahead and create new projects that use your own little mini framework to, sort of. So you can go ahead and make new little frameworks based on modifications to existing ones. You don't need to leave all of the advancements in stuff that they do behind. If they did something really great, that's fine. You're still using it. And of course, the fun bit, especially for a company, is you could subclass a framework for company-specific additions. Maybe your company always puts on a little bit of a sign-on scheme. Maybe they always make a somewhat uncommon in the wild database connection. Why do you want to keep on doing the same little bit of tedious work over and over again every time you make a new little web application for your company? You probably don't. You can go ahead and inherit from another framework that does almost everything you want and go ahead and make those few little changes, and now you get to stay with those every time you make a new project. So essentially, WSGI goes ahead and it enables reuse and collaboration. And assuming this works here, I'll go ahead and pull up a little demo of this. Any questions so far? No? Okay. Can everybody see that fairly well? So, I'm going to go ahead and take a look at all the templates I have available. These are project templates, so if you go ahead and add new ones, you can go ahead and see which kind of projects you can create. If you want to create your own Google project that has your sort of starting point for an application that you would develop here, sure, no problem. You could go ahead and make one. So I'm going to go ahead and create. I want to use the Pylons template, and I'll call a little project blah. And it goes ahead and creates a project for me. So that's all it gives me to begin with. And then this is already set for distribution. It has a setup.py file in it. It's packaged the entire application under another directory underneath it. And it's ready to be packaged up and distributed as well. So you sort of get all of that for just, when you're ready to get started. It's already packaged itself up as a distributable application. So I'm going to go ahead and add in a little controller here. And here we have our controller. It's pretty basic. This is the one that was just created. Let's see if I could go ahead and blow this up a little. Let's go ahead and take a look at what this does so far. It's probably not going to be very interesting. We'll go ahead and start up the application. And now it's all running, ready for us to take a look at it. So if we go, huh?
What's the file monitor? Is that some sort of wrapper with FAMD or?
Oh, for the reload?
Yeah, file monitor.
Oh, on the side of the window back there?
Starting subprocess with file monitor.
That sounds like something Shopify does.
Yeah, that's inside of Paste. It goes ahead and watches all the Python modules that were loaded and involved to detect when one of them changes and reloads the application. So here's the default screen that you see when you start up. And we went and added a users one at the end here, which returns nothing, so it should be blank. Not very exciting so far. And let's go ahead and play with the interactive debugger because that always looks great for demos. That's going to cause it to restart. And we'll reload that, and we should get a nice little interactive trace back there. So this is one of the little things that you get for free because it's provided by middleware. And I'm not sure why all Python web applications don't come with something like this now, because it makes things really easy to debug. There we see our controller that threw our error. Arrow is raised. Ah, that's great. What were the variables that are around during that time? Well, that's a good start. But what else can we do in here? And right here, you got a full interactive Python interpreter. So we could go ahead and take a look around and evaluate what we have available to us. And sure enough, everything is right there. Very handy, very easy to debug, especially if you have a lot of objects that are wrapped up inside of each other. Sometimes just listing, okay, great, I have an object here, that's not going to really help me a lot. But here, you got to use an interactive Python debugger pretty much anywhere in your entire stack traceback. And that's mainly because of paste eval exception. Again, we have middleware that does the work, so I didn't need to write this, which I love because I like getting free functionality that other people have written. Whoa. So, any other questions? That's it. Thank you very much.